One command, that's it.
One command and you have root access on every major Linux distribution on the planet. No race condition, no brute force, just a clean, deterministic logic law that's been hiding in the kernel for 9 years. Every server, every container, every cloud VM, every Raspberry Pi running your smart home. If it runs Linux, it's vulnerable. And the proof of concept exploit is already public. They're calling it Dirty Frag. If you're keeping score, that's Dirty Cow, Dirty Pipe, and now Dirty Frag. The Linux kernel's tradition of catastrophic vulnerabilities with cute names continues. The researcher who found this is Hyunwoo Kim. He disclosed it responsibly through the kernel security team. The plan was a coordinated release, but on May 7th, a third party independently discovered the same bug and published a full exploit. The embargo shattered. Dirty Frag isn't one bug. It's 2. CVE-2026-43284, a flaw in the kernel's IPsec packet fragmentation code, and CVE-43500, a flaw in RxRPC page cache writes. Chain them together and you get deterministic local privilege escalation to root. Quick kernel lesson. XFRM is the Linux kernel's framework for IPsec. Encrypted network traffic. ESP is encapsulating security payload. When an encrypted packet is too large for the network, the kernel fragments it. The fragmentation handler has a logic law that lets an attacker overwrite adjacent memory. The second bug is in RxRPC, a remote procedure call protocol used by AFS, the Andrew file system. Its page cache write path doesn't properly validate page ownership. Combine that with the memory corruption from the first bug, and you can write arbitrary data to kernel memory. Game over. Here's what makes Dirty Frag different from most kernel exploits. It's deterministic. No race conditions. No heap spraying. No prayers to the scheduler gods. You run the exploit, it works. First try, every time. That's the kind of reliability that makes sysadmins lose sleep. These flaws were introduced in kernel 4.13. That was 2017. 9 years. 9 years this has been sitting in the kernel source code, reviewed by thousands of developers, scanned by countless static analysis tools. Nobody caught it. Let's talk blast radius. Linux runs 96% of the top million web servers, every single one of the top 500 supercomputers, over 90% of cloud infrastructure, and 72% of smartphones through Android. This vulnerability affects all of it. The attack path is absurdly clean. An unprivileged local user triggers the XFRM fragmentation bug to corrupt adjacent memory in the page cache, then uses the RxRPC write path to escalate that corruption into a full kernel memory write. Unprivileged user in, root out. And before you say you're safe because you're running containers, you're not. Dirty Frag works as a container escape under default Docker and Kubernetes configurations. No special capability, no privileged mode. The container boundary is a user space construct. The kernel doesn't care about your namespace. In cloud environments where multiple tenants share a host kernel, which is more common than cloud providers want to admit, one compromised VM can escalate to root on the host. From there, it's lateral movement to every other tenant on that physical machine. Your neighbor's bad day becomes everyone's bad day. The disclosure timeline is a mess. Hyunwoo Kim reported it responsibly. The kernel team was working on fixes. Then, on May 7th, someone else independently found the same bugs and dropped a full proof of concept online. The ESP patch was rushed into upstream that same day. The RxRPC patch still pending. So right now, the Linux kernel is half patched. The ESP fragmentation bug has a fix merged upstream, but the RxRPC page cache bug, the second half of the chain, is still unpatched. And while the full chain requires both, the RxRPC bug alone has its own attack surface that researchers haven't fully mapped yet. The distro response has been fast, but incomplete. Ubuntu and Alma Linux published advisories within hours. Debian, Red Hat, and SUSE are still working on their patches. And every enterprise that runs a custom kernel, which is most of them, has to backport the fixes themselves. Dirty Frag joins an infamous lineage. Dirty Cow in 2016, a copy-on-write race condition. Dirty Pipe in 2022, a pipe buffer overwrite. And now, Dirty Frag. Fragmentation meets page cache corruption. Each one was catastrophic. Each one was hiding in plain sight for years. The Linux kernel is 38 million lines of code, maintained by over 20,000 contributors. But critical subsystems like XFRM have maintainer lists of 3 people. 3 people responsible for the IPsec code running on every server on Earth. The kernel's biggest strength, its scale, is also its biggest vulnerability. What should you do right now? Check your kernel version. If it's 4.13 or later, you're affected. Apply the ESP patch immediately. Watch for the RxRPC patch. Restrict unprivileged user namespaces if you can, and audit your container runtime configurations. Default settings are not safe. The real danger window is right now. The proof of concept is public. Script kiddies can run it. Nation states definitely already have it, and the full patch isn't isn't available yet. Every hour between now and the RxRPC fix is an hour where every unpatched Linux system is a target. The bigger lesson here isn't about one exploit. It's about the foundation we've built everything on. Containers, VMs, cloud isolation, multi-tenant security, all of it depends on the kernel being correct. One logic flaw in a subsystem maintained by 3 volunteers and 9 years of trust evaporates in a single command. Dirty Frag, 2 CVEs, 9 years in the kernel, 1 command to root, half patched as of today. If you run Linux, and statistically you do, patch now. Subscribe so you don't miss the next one that breaks everything.